Devion our Sajano, Namaskar. Today, we explore a machine that has transformed our world, the computer. It's not just a glowing screen or a humming box. It's a device that follows instructions, processes information, and delivers results. Computers help us learn, connect, create, and even save lives. They're woven into every part of our existence, making the impossible possible. The story of the computer is really the story of human curiosity and our quest to solve problems. Its roots stretch back thousands of years, long before electricity. From simple counting tools to today's supercomputers, this journey is filled with brilliant minds and world-changing breakthroughs. We'll meet pioneers, witness the birth of giant machines, and see how they shrank to fit in our hands. This is the story of the computer, a journey that has reshaped our planet and our lives. Prepare to be amazed, because the story of the computer is, in many ways, the story of us. Let's begin this wonderful game of knowledge. Our story starts in the ancient world, where people needed to count and keep track of things. They used fingers, stones, and marks. But as life got complex, they needed better tools. Enter the abacus, a frame with beads invented over 4,000 years ago. It let people calculate quickly and accurately, freeing their minds for creativity. In ancient Greece, the Antikythera mechanism appeared, a complex device that predicted astronomical events. These inventions proved that machines could handle calculations and track information. They weren't computers as we know them, but they were the first steps. The abacus and Antikythera mechanism are the ancestors of today's computers. They laid the foundation for all future innovation. Fast forward to the 1600s, an era of scientific awakening. Blaise Pascal, at 19, built the Pascaline to help his father with tax calculations. This brass box could add and subtract automatically, a leap from the abacus. A few decades later, Gottfried Wilhelm Leibniz created the stepped reckoner, the first machine to multiply and divide. These devices showed that logical operations could be built into machines. Pascal and Leibniz proved that human reasoning could be mechanized. Their work laid the groundwork for the future of computing. They sparked the dream that machines could not just count, but think by following rules. In the 1800s, Charles Babbage dreamed of error-free calculations. He designed the difference engine and then the analytical engine, a programmable general-purpose computer. The analytical engine had all the basic parts of a modern computer: a mill, CPU, a store, memory, and punched cards for instructions. Babbage's vision was ahead of its time, but he couldn't build it. Ada Lovelace, a brilliant mathematician, saw the machine's true potential. She wrote the world's first computer program and imagined computers creating music and art. Ada became the prophet of the computer age. Together, Babbage and Lovelace gave us the blueprint for every computer that followed. Babbage's dreams waited nearly a century for technology to catch up. The next leap needed electricity, and the urgency of World War II. Alan Turing, a British genius, imagined the Turing machine, a model for all computation. During the war, Turing helped break the German Enigma code, saving countless lives. In America, John Mauchly and J. Presper Eckert built ENIAC, the first general-purpose electronic digital computer. ENIAC filled a room, used thousands of vacuum tubes, and could perform thousands of calculations per second. It marked the start of the mainframe era, as companies like IBM saw the future in electronic brains. These machines ruled computing for decades, powering science, business, and government. Computers evolved in generations, each smaller, faster, and smarter. The first generation used vacuum tubes, huge, power-hungry, and unreliable. The second generation arrived with the transistor, smaller, faster, and more efficient. Programming became easier with languages like Fortran and COBOL. The third generation brought integrated circuits, hundreds of components on a tiny chip. Computers shrank, became affordable, and entered businesses and universities. The fourth generation saw the microprocessor, an entire CPU on a single chip. Now, computers could fit on a desk, setting the stage for the personal computer revolution. The microprocessor, invented in 1971, put the power of a room-sized computer on a tiny chip. Suddenly, computing was for everyone, not just big companies. Hobbyists and young innovators built kits and early machines in their garages. Apple and Microsoft emerged, launching the Apple II and MS-DOS-powered IBM PC. The 1984 Apple Macintosh made computers user-friendly with a graphical interface and mouse. Microsoft's Windows soon dominated the PC market. Personal computers became as common as TVs, changing how we work, learn, and create. PCs empowered individuals, democratized information, and opened new creative frontiers. The world was now at your fingertips. Type, click, create. The true power of computers emerged when they connected, ushering in the internet. Born from the 1960s ARPANET project, the internet was designed to survive disaster and share information. For years, it was used by scientists and the military. In 1990, Tim Berners-Lee invented the World Wide Web, making the internet visual and easy to use. The Mosaic browser let anyone surf the web. Companies like Google, Amazon, and Facebook were born, and the world rushed online. The internet erased boundaries, transformed commerce, and changed how we communicate. It gave a voice to the voiceless and connected humanity like never before. The internet is now the central nervous system of our civilization. Just when we think technology has peaked, it leaps again. We're now in the age of artificial intelligence. Machines that learn, reason, and create. AI, once a dream, is now reality thanks to powerful computers and vast data. Machine learning lets computers learn from data instead of explicit instructions. It powers your spam filter, movie recommendations, and voice assistants. The next frontier is quantum computing, using qubits that can be 0, 1, or both at once. Quantum computers could solve problems impossible for today's machines. AI and quantum tech are not just improvements, they're a fundamental shift. They could revolutionize medicine, climate science, and more, but also raise big questions about our future. The journey from counting beads has brought us to the edge of new intelligence. Now let's bring our story home to India. For years, computers were rare here, but a digital revolution has swept the nation. The IT boom of the 1990s and 2000s put India on the global tech map. Cities like Bengaluru and Hyderabad became software hubs, creating a skilled workforce and new entrepreneurs. The Digital India initiative aimed to empower every citizen with technology. Affordable mobile data brought the internet to millions, bridging the urban-rural divide. Today, India has one of the world's largest populations of internet users. The smartphone is now a tool for education, healthcare, and opportunity. India's digital journey proves that accessible technology can unlock a nation's potential. The future of computing is being written right here, in the heart of India. We've traveled from counting beads to building machines that think. The computer's story is one of relentless curiosity and human ingenuity. It's about visionaries like Babbage, Ada Lovelace, Turing, and millions of unsung heroes. The computer is a monument to our collective intelligence and dreams. Today, it's an extension of ourselves, enhancing memory, intellect, and connection. It shapes how we learn, work, and communicate. As we enter the era of AI and quantum computing, the journey continues. The spirit that drove the first abacus still drives us to build the future. This is a story worth celebrating. Thank you.